Okay, question 5. Question 5 is asking us for the energy of the ground state of hydrogen. And so I have an H atom, and that's a single electron species, so I can apply the formula where the energy of any level that's defined by n is equal to the negative value of z squared RH over n squared. For hydrogen, Z is equal to 1. My atomic number is 1. And the ground state, which would be the lowest level, is, you guessed it, n equals 1. So actually, again, I don't need the calculator here, do I? And I don't think I did this on purpose, but anyway, as it turns out, I have the same answer for 2 questions here in line. The energy of the ground state, so n equals 1, is equal to the negative value of 1 squared, because my atomic number is 1, times 2.179 times 10 to the minus 18 joules, my numerical constant R sub h, so that distinguishes it from the gas constant R, by the way. And it's n equals 1, so I have this 1 squared. So again, I see that these things are going to cancel. I'm going to maintain that negative sign, and it's really the negative value of my R constant. So 2.179 times 10 to the minus 18 joules. So that's the value, and again, it's a negative value, and I tried to explain that in class and a little more, or again, rather, on the last question. This is the answer to the last question. But again, if I can just move this up for a second, imagine our nucleus of the hydrogen atom, and then I have this first energy level all the way around it, where n is equal to 1, and I have this electron sitting here. And in this particular question, it's not asking me what's the energy of the electron in the ground state. It's just asking me for the energy of the ground state. Now, realize that the solution would be the same, and so I'm preparing you for the fact that the answers are the same. And the truth is that the energy of the electron in this ground state, it must be the same as the energy of the ground state. Right? They have to be in phase, they have to be equal. So whether I'm asked for the energy of the electron in the first energy level, or I'm asked for the energy of that first energy level, or ground state of H, same calculation, same answer, and a negative 2.179 times 10 to the minus 18. So while we have this, and while we have this drawn, let me just take the liberty of adding, and instead of doing the full circle, can we just focus maybe on one radial segment moving out? Let me just sketch in what might be n equals 2, and then a little bit closer here for n equals 3, just for a second. So the energy of the first level is, we saw, minus RH, or minus 2.179 times 10 to the minus 18. Think about what would the energy of the second level be for hydrogen. I'm still using this formula. Z is still 1, so that's 1 squared, but this would be, n is 2, so that's 2 squared. So do you see how at the second level my energy is going to be equal to a minus RH over 4, isn't it? It's a quarter of the RH value. Do you see why? Because I use this is RH, my negative sign's there, Z is 1, but n is 2, so I have a denominator of 2 squared, or 4, right? And let's just fill this in here. So that was 2, and the energy, whoops, not there, but the energy of the first level was a negative value of RH. So tell me, what is the energy value for the third level? E of the third level is 1 squared times that over 3 squared, right? So it'll be 1/9 of the RH. All right, just another way of thinking about it, not having to use our calculators. Okay, so we kind of did a little more than what question 5 was asking us for, but just it's fun to expand it a bit. So we'll end it there.